Hello. Today we'll be discussing 1.3 linear functions. We'll go over another approach for graphing linear functions and define parallel and perpendicular functions. All right, as you can see in this graph, you have kind of that parent function of f of x equals x right here. That is the basic equation of a line. Now we can grab that function and shift it up or down, right or left. That's the other approach of thinking about how to graph a line. Notice the B acts as a vertical shift. So when I have f of x equals x, and then I add 2, I just take that kind of anchor point at 0, 0 and shift it up 2. If I add 4, I'd shift it up 4 as seen here, and the same thing as going down. If I grab that anchor point and shift it down 2 or down 4, then you can see the same thing happening here. That's how you can think about graphing the equation of a line using a vertical shift. The other idea we want to cover today are the definitions of parallel and perpendicular lines. What does that mean and how can it help us? Notice parallel. We know that concept from the real world. Parallel. They're two lines that will never intersect. If they never intersect, what does that mean? Parallel lines have the same slope. Notice parallel, two L's, and same slope, two S's. A little alliteration there for you. Parallel lines have the same slope. But what do we know about the y-intercepts? They are different. The same slope and different y-intercepts. Notice I have a y-intercept here below the origin, and this line has a y-intercept here above the origin. Can I take that line and make another parallel line that has a different y-intercept? Yes. That's why when we're working algebraically without the graph, you need to make sure that you only know about the slope when working with two lines. You don't know about their y-intercept because you could have a million lines with the same slope but different y-intercepts. All right, what about perpendicular? Well, we know that forms a 90-degree angle. What do we know about perpendicular lines? Their slopes are opposite. So we're talking about the signs. So this one's positive, that one's negative. So they have opposite signs. They are opposite reciprocals. Reciprocal just means flip it. So notice here is 2/3. The reciprocal is 3/2. Here's another example, 5/4 and negative 4/5. They are opposite because one is positive and one is negative, and they're reciprocals because they're flipped. Likewise, 3 and negative 1/3. So when you just see a whole number and think, oh no, we can't take the reciprocal. Yes, you can. It's always divided by 1. Notice 3 is the same as 3/1. All right, let's try one. Given 6x minus 7y equals negative 14, what's the slope of a line parallel and the slope of a line perpendicular? Notice they're only asking you about the slope. They're not asking you about the y-intercept because we don't know. That doesn't give us any information to know about the y-intercept from a line that is parallel or perpendicular. Okay, well, first of all, we need the slope. So we need to change this into slope-intercept form by subtracting the 6x. So negative 7y equals negative 6x. And then dividing by negative 7. So divide both sides by negative 7. So y equals a positive 6/7 x blah, blah, blah. I don't care about the y-intercept because it doesn't help me finding a line that's perpendicular or parallel. All right, what is the slope of a parallel line? It's exactly the same as the one I have. So the slope m would equal 6/7. What is the slope of a perpendicular line? Well, we'd have to be opposite. So the slope m would be opposite, which would be negative. and then we take the reciprocal. So -7/6. All right, hopefully that helped you understand a little bit more about parallel and perpendicular lines. We'll see you next time.